Hello guys, welcome back to my channel, and those who are new to this channel, kindly make sure that you subscribe to this channel for the latest tech updates and the tech knowledge so you don't miss any, right? So in our previous video we talked about the measures of the central tendency, that is the mean, the mode and the median, and this all tells us at the center of the data. Now today we will talk about the measures of dispersion. Measures of dispersion. Now you would be wondering like what dispersion is. So talking about the dispersion first, the dispersion tells us how spread out the data is. How spread out our data is. So talking about the variance first. So there are basically, three types of the measures of dispersion, which are the variance, the standard deviation, and the interquartile range. And we would be talking about that in detail. So let me write these three terms first, so you are not confused. So we have like variance, standard deviation, and the interquartile range. Interquartile range. And we also refer to it as IQR. So talking about the variance first. So before that, let me talk about the dispersion. So for example, you have two data sets, okay, and two data sets can have the same mean but different spreads. For example, you have the first data set as like you have an A data set which has like 49, 50 and 51, and you have another data set which is 10, 50 and 90. So they mean, so both of their mean would be 50, okay, so both of their mean would be 50, but the data set 1 is tightly clustered but the data set B is widely spread, and without dispersion we miss the variability story, okay. So let me write this for you also, that data set 1, this one is tightly clustered, while our data set B, that is this one, is widely spread. You know that 49, 50 and 51 are very close to each other, while the 10, 50 and 90 are far, the far away from each other. Now talking about the variance first, so we denote the variance with the sigma square or the S square. So talking about the definition, variance is nothing but the average of the squared differences from the mean. Average of squared distances from the mean, okay. So talking about the formula, so we denote the variance of the population with this sigma square, okay. So the formula is summation of xi is the data point, minus the nu is the mean, whole square divided by capital N. And there is one more, that is the variance of the sample, whose formula is similar, just a small difference in that. So summation of xi is the data, individual data points, nu is the mean, then it's square, and then we write n minus 1. So we can also write this nu as x bar also, so that it's differentiated, nothing much more, okay. And talking about its example, now let's talk about one of the example of the variance, okay. For example, we have a data set, okay, whose values are like 60, 70 and 80, okay. Now its mean is 70, that is 60 plus 70 plus 80 divided by 3. Talking about the difference, so 60 is minus 10 from 70, 70 from 70 is 0, while 80 from 70 is plus 10. Talking about the squared difference, what if we square it? I'm just squaring this above values, okay. So minus 10 square is 100, 0 is 0, and 10 is 100. Okay, now talking about its variance, what would be its variance? Its variance would be what I said, the definition, average of the squared distances from the mean. So are these square distances? Yes. So we will take just the average of these. So 100 plus 0 plus 100 divided by 3, which is 200 divided by 3, which is 66.7. So variance is nothing, variance is just the average of the square distances from the mean. So variance is in squared units, so its unit would be score square. Okay, this is units because the unit of variance is squared units. Okay, so remember this is the most asked question in the interview. So it's let's intuitive. Okay, so the variance is basically now let's intuitive, talking about the standard deviation. So standard deviation is nothing but the square root of the variance, square root of variance. Okay, so its formula is sigma is equals to under root of sigma square. For example, the variance is 66.7, which we calculated in our previous state. So its standard deviation would be under root of 66.7, which is 8.16 approximately. Okay, so our interpretation on this is that on average score deviates 8 points from the mean. So how would you read this? You will read this as that on average score deviates 8 points from the mean. Okay, so the standard deviation brings the dispersion back to the same units as the data, making it easier to interpret. Now talking about the interquartile range, so interquartile range is nothing but the spread of the middle 50% of the data. It is nothing but the spread of middle 50% of the data, middle 50% of the data. And by the formula we can write it as IQR is equals to Q3 minus the Q1. For example, we have a data set. Okay, for example, we have a data set in which we have values like 10, 15, 20, 25, 30, 35, and let's say till 40. Okay, so our Q1, which is the 25%, would be 15 because 1, 2, 3, 4, 5, 6, 7. So 25% would be 15. Our Q3 would be 75%, which is 35. And our Q2, which is the 50% or the middle value, will be 1, 2, 3, 4. That is 25. Okay, so what would be our interquartile range? Our interquartile range will be Q3 minus Q1, which is 35 minus 15, which is 20. So the basic drawback of it is that the IQR ignores the extreme values and focuses on the bulk of the data. So I want to talk about this in the outlier sensitivity also. I know the video is quite long, but it is necessary. So you need to, know this. So talking about the outlier sensitivity. So the mean is, distorted by outlier, as I have mentioned is. So talk, for example, okay, let's take an example. Our data set has a values like 30K. These are the salary of the employees. 40K, 45K, 50K, and let's take one outlier, that is 500K. So our mean would be 116.7K, and it is distorted by outlier. While our variance is huge. our variance of the data or the standard deviation of this data will be extremely huge, because the squaring amplifies the 50k deviation. The squaring of 50k would be a huge number, but when we would take the median, it would be unaffected. Not talking about the IQR is the like middle 50%, still the 15k spread, and it's robust to outliers. So variance and the standard deviation are sensitive to outliers, while IQR is robust to outliers, and the variance is sensitive to outliers. Okay, so where this appears in machine learning, in the variance and the standard deviation is used in the loss functions like the MSE and the RMSE. So let me write this for you. So this is used in the loss function. Okay, loss function like the MSE or the RMSE. Okay, and the feature scaling, it is also used in feature scaling. Let me write this for you. Feature scaling or the standardization, and it's also used in the PCA, that is the principal component analysis, and this mainly relies on the variance, while our IQR is used for the outlier detection before training, used for the outlier detection before training, and robust statistics for the skewed data, and it's also used for the robust statistics for skewed data. Like the income or the house predictions. So, summing up all the things we learned today, we learned about the variance, which is the average square deviation, and it's a mathematical foundation. Then we learned about the standard deviation, which is the typical deviation in the same units, and it's more intuitive, talking about the interquartile range. So, interquartile range is the spread of the middle 50%, and it's robust to outliers. And always check the dispersion to understand the variability before the modeling. So, this was all for today. Hope you like the video. Just so if you like the content of the video, just like this video, subscribe my channel, and do not forget to hype my video. Meet in the next video of 20 days of statistics. Till then, bye bye.